So guys, if we again start the session from where we left the things last time, we were on something called subnetting, and we completed something called C-class subnetting. Now, in C-class subnetting, right? You know what is C-class networks? Are those networks which have range from 192 till this is about C-class networks. If the first octet is from 192 to 223, yes, that is supposed to be C-class networks. Okay, so I'll complete this C-class sub subnetting example, and then
Ganesh sir, your screen is not coming.
okay. Okay. So we did. Are you able to see my screen now? Yeah, I think so.
No.
Now you can.
Yes, yes. No,
So we completed that C-class subnetting, right? And in C-class subnetting, we saw how we can subnet C-class networks. But when I talk about C-class networks, if I talk about what is the default network, for example, I'll take this network 200.100.10.0. But this is the default network for uh, C-class. This is one example of how a C-class network would look like by default, right? So when I write /24, right, it is the default network, and I've written it in CIDR notation. I can also write this as 200 dot. I can either write it like this or 200.100.10.0, 255.255.255.0. Now when I write the network address like this, or like uh, like the representation that I've done in the second part, the expanded notation, right? It means the same thing, right? Now if I want to convert this into binary, I want to remind you how we arrive at subnetting solutions, right? The solutions to the questions which are there for subnetting. So I'll drop it as I'll write it as 8 months followed by 8 months. This is how we write the subnet mask for C class, right? This is how the subnet mask is written. So it is 24 ones followed by 8 zeros, right? And how do we arrive at subnetting? In subnetting, when I say generally we used to say earlier that 255 means network, right? And 0 means host. And if I convert this into binary, right, I'll write the same thing as 1. If a bit has value 1, it is host. If a bit has value 0, it is network. This is important again to remember. And these are the three ways how in which we can write network addresses. Right, one is CIDR notation, one is the normal expanded notation, and obviously we at times have to bifurcate this into binary so that we can understand things in a better way. So the first question about this always is how many number of networks will be there if I divide this into subnets, right? And as I told you in the previous session, when I say I want to divide this into a smaller network or something, right? What we do is we change the subnet mask into something else. And what can we change the subnet mask into? Right? We can change the subnet mask into something which has more number of ones or more number of sorry, this is written a little bit wrong here. One in binary, one is equivalent to something called host bits. So I'll just change this now. Just write this down. Right, so this is not correct. Uh, Although I think I spoke properly, but I wrote it in the wrong way. So write it again now. So it's one when host bit is the value of host bit is one, right? Then it's called as the value of bit in separate mask is zero. It is called host bit. Now carrying this forward, if I say I want to increase my networks, right? I want to subnet my networks into, for example, I have a one big network, right? Slash 24. I want to subnet into smaller networks. What do? I change the subnet mask by increasing number of ones. When I increase number of ones, this value of slash 24, right? This will increase. What will this become? For example, in my question, if I say what's my question, right? So in my question, I'll get a question like this, right? 200.100.10.0 slash, I'll say 28, right? So this is how a subnetted question will look like. So you need to convert this CIDR notation into the normal expanded notation. And I gave you that table to convert CIDR into into the normal decimal number system. Uh, that's some expanded subnet mask. So slash 29 would be written as 255. So if you don't know how to write over here, there is a table there, or else what you can do is say 25525 will stay like this. Just the default, that is where we increase the number of ones. So let's write before I write in the expanded notation, in case you don't know what to write in this. So let's write this subnet mask as the binary. This we already have, right? This is something that we already had. Uh, 24 ones are already there. We just increase the number of ones that we have. So we will write 29 number of ones. 24 are already there, so we'll write 5 more ones now. 1, 2, 3, 4, 5, and last one is 3 zeros. This is how we'll write the subnet mask. When I write this subnet mask and I want to convert this into, now the expanded notation, I'll convert this binary into decimal and I'll get my expanded notation. So it is 255.100.10.0, right? You'll get it 248. When you convert this 5 ones and 3 zeros, you get this 248, right? And I've already given you that table, so you can just remember this table here also if you want to. So when you convert this zeros to ones, right, you get these values in subnet mask 0, and then you get 128, then you get 192, then you get 234, then you have the next value 240, 248, then you have 252, and last one 253. This is what we have. And before you start doing any question, when we do this B and A class also submitting, you make sure you have all this information scribbled on your notepad, even if you know it, because this will help you to remove any kind of errors when we start doing B and A class. So you should have your network address in CIDR notation, your network address in expanded notation, and the binary conversion of that, right? uh, that entire network address along with the default subnet mask in both the notations and the binary. Now we can clearly see from this this entire thing that has been written over here in this whiteboard, that the total number of ones that we have converted now is 5, right? If you compare the number of ones that we had earlier, how many number of ones we had earlier? 24. And how many ones we have now? 29, right? So how many ones we have converted, right? We have converted 5 number of ones. So that is one thing we have to remember. And we'll go to the first question now. The first question is how many number of network addresses will be there? Number of network addresses will be there, and number of networks that will be formed if I use this subnet. When I'm using slash 29, obviously I've divided this network into smaller networks, right? So networks I have divided it into. So to find the formula for this is 2 raised to power n, right? I'll write raised to power as okay, 2 raised to power n, right? And that's it. Where n is equal to number of networks. N is equal to number of network means what? Network means number of ones, right? And I have to also make sure that I write things properly. So number of networks borrowed. Borrowed means the ones which we just converted, not the total number of ones. So the total number of ones that we have in this question is, in this question we have the number of ones as 29, right? But out of which 24 were already there with me when I started out with the default subnet mask. So n here will be equal to 5, not 29. So I'll write a number of networks. My first question which I'm trying to figure out here is what is number of networks I have. So the answer to that will be that I will have somewhere around 2 raised to power 5 networks, which is somewhere around 30. Okay. So we move on to the next question now, which is number of hosts or subnet. So every subnet will have some number of hosts. We will not have the entire big subnet now. We have small subnetworks. How many subnetworks we have? We have 32 subnetworks. And how many hosts do we have each subnet? We have I given by 2 raised to power again m, right, minus 2. Now this is in bracket actually. This is what we have. 2 raised to power m minus 2, right? So it is 2 raised to power m minus 2, which means m, where m is equal to number of remaining zeros, right? M is equal to number of remaining zeros. Number of zeros or host bits which are remaining with. So how many zeros I have been left with when I'm using slash 29, which is my question. So number of zeros that I have here, 3 now. So my answer will be 2 raised to power 3, right? Is how much? 2 raised to power 3 is 8, right? And then minus 2. So be little careful when we do this because I'm not able to represent it here properly. So I'll just write it in a little proper way. Let me show you how this might be written. So like this, just 2 raised to power m minus 2. Okay. So when I write this, right, if I say 2 raised to 3 minus 2 is how much? 2 raised to 3 minus 2 will be 8 minus 2, which is equal to 6. Right? So we'll have 6 hosts in each subnet. Right? So I have this network which is the base network, right? And I subnetted it using slash 29, and I wrote this in all the possible ways. I wrote this in slash notation, I wrote this in expanded notation, I wrote this in the binary form also. Although this is not necessary as of now, also write all the values which can be there, right? So it is 0, 128, 192 and all. And then find the answer to first two questions, number of networks and number of hosts per subnet. Now you move on to the next, you can say, uh, the next section of this is which is there. So I'll just rub some things over here. Right? I want some space in this whiteboard. I want to complete this in this single screen only. So the next question is, if I have 32 networks, right, I want to find network addresses of all the networks which are there, right? So if I had one network, what is the network address? Network address was 200.100.10.0/24. When I have 32 networks, I'll have 32 network addresses for each of the networks, because every network will have a separate network address, right? So I used to say this. This is how I draw this. So this is my one network that I have, right? I have subnetted it using /29, right? I'm writing trying to write it in some chemistry style, right? So I've divided it into 32 networks. So I'll have what, 16 like that. Right. So I'll divide it into so many number of networks. I have not drawn visually correctly, but I'll have 32 networks there. So if this one network has network address 20.200.100.10.0/24, these networks, these smaller networks, this one, right? These networks which I have drawn here, right? These will have its their own network addresses also. I'm trying to find out now what is the network address of each of the network that I've created now after I've used this /29 as the subnet mask. All right, so we move on to this third question, which says, what is the network address? What are the network addresses to find network addresses, right? That which is the again the next section for this. We find something called block size. Find something called block size. So how is block size found? Block size is found by this is very important. Block size is found by subtracting from 255 always. So this is a formula. 255 will subtract the value of something called interesting octet. If you see, interesting octet is found by comparing the default subnet mask with the subnet mask that we have in question. So default subnet mask is 255.255.250 for C class addresses, and default subnet mask, so the subnet mask in question is 255.255.248, right? So block size for this is 255 minus the value of interesting octet. Sorry, 255 minus 248. Right? So remember, interesting octet is any octet which is changing from when I compare this with the default subnet mask. So if in my question there is only one octet which is changing, which is the fourth octet, right? So that is my interesting octet. So this becomes my interesting octet, 241. So that is why I'm subtracting this value 250 from 255. So what do I get after this? Right? I get, if I subtract from 250, not it's subtraction is not from 255, it's from 256. So I'll write it once again. I just want to cut this out. So this is, I write it again. This is block size will be 256 minus 256 minus 248 will be 8, right? So 8 is my block size. When I write 8 here, I also have to remember for which octet I have calculated this block size. The block size is calculated by marking this fourth octet as interesting octet. So that becomes my interesting octet. So I'll write it as fourth octet. So the value of block size is 8 and the value is for fourth octet. Okay. So the value that I have to focus on is this one, 8. Right. So how do I find network addresses? I'll write the base address from the top. Base address means the address which was the network address always, which is 200.100.10.0. This was already a network address, and we'll keep on adding the block size to the interesting octet until we do not get to some invalid value, right? 200.100.10.0, next we move to 200.100.10. I'll add 8 to the last octet, so I'll get 200.100.10.8. Now when I'm using /29, I'm solving this question. For /29, 200.100.10.0 is a network address, and when I add 8 to it, I get another network address. right? Similarly, when I keep on adding 8 to it, I'll get this 210.16 now, and I'll get the table multiplication table of 8 now, right? So 8, 16, 24, and all this, right? It will go on till some this place, right? So it will finally end up at 200.100.248. Once I add again 8 to it, right, I'll get 200 or 100 or 10 or 256, right, which obviously I cannot write. So these are all the network addresses that I have, right? So I'll have total of 32 network addresses if I draw it here. So if I count over here, so I'll have maximum. So this total will come out to be 32 network addresses. So it will be 210.0, 110.0, 10.8, 10.16, 24, 32, likewise until 248. I'll not be able to write beyond 248 because when I add 8 to this, I'll get 256, which is not a valid value, right? So I come to the last part of my question, which is here, which is the right here, which is valid host addresses, right? So I'll have the valid host address range and broadcast address. Now, when I talk about this slash 29, I have from slash 29 I have got 32 networks, right? For each network I'll have valid host range, from where, from which IP to which IP address I have the valid host that I can give for a particular network. So I'll select one particular network. For example, I'll select this 8, right, for this last part. Now when I select this 8 as my network which I have to answer about, right, I write this network as this, right? I'll write it as 200.100.10.8, right? So I'll write this as a network, and what is the first valid host for this network? I'll get it by adding 1 to it, right? I'll get it by adding 1 to the last octet, right? 200.100.9 is my first address, right? And then I'll get 100.100.10.10, right? I'll keep on writing it, keep on adding 1 to it until I do not get to the next network address. What is my next network address that I have according to this question? So next network address is 16. So 16 is already the next network address. So I'll not go beyond 16. I cannot even write 16 because 16 is already my next network, right? So what is the last address that I can write in this series? So the last address is 16 minus 1, which is 15. So I'll write it so 200.100.10. I'll write it in a separate box. Okay, so I have 200.100.10. Last address. So the last address of any network, for example, when we used to have the default subnet mask and all, the last address for any network is called broadcast address. So similarly here also the last address for this network, for the network 200.100.10.8/29, right? So that will be the broadcast address. What is the broadcast address now? 200.100.10.15, which is the last address. So this becomes my broadcast address. Remember, all this calculation is because I've changed the subnet mask from slash 24 to slash 29. So when I write 200.100.10.8, this is a network address only if I use this subnet mask slash 29, right? So I've got this broadcast address, and if I subtract one more from this broadcast address, I'll get 200.100.10.14, right? So 200.100.10.14 will be my last address, last valid host address. So what are my valid host address that I have, addresses that I have? So I'll write them here now, right on the left hand side, top left hand side. So I'll have addresses from 200.100.10.8 as my first address, and what is my last address that I calculated now? 200.14, right? So these are the two minimum and maximum addresses that I have in this network, right? In the network that I have. So first address is 9 rather. because 8 is my network address. So 9 till 14 and 15 is my broadcast address for this network, right? 200.100.10.15 is broadcast address. So from 9 till 14 I have the total number of host addresses that I have. So how many addresses we have if I calculate from 9 6? So we had 6 as my, say this, number of hosts which were there. If I again find it, 6 were the number of hosts, and these are the 6 addresses that I have in this network. Similarly, if I want to find addresses in the network number 200 or 100 or 10.16, what addresses will I have? I'll have addresses from 17 till 22, right? Because 23 will be the broadcast, 24 will be the next network address. So this is how we keep on solving these subnetting questions. Whenever you get time for something, right, try to practice it with other subnets, like try to practice any C class network address. You keep this network address as 200 or 100 or 10.0 or any network address that you want, and you put it for slash 27 or slash 29. This is something you can practice on your own, this particular question. And we move on to something called B class now. Right? I hope you're able to understand this subnetting as of now. So, in case you're not able to understand something, just raise a question. Yeah, one is network, zero is host. I think I wrote it incorrectly. So we have now B class originally wanted to start with now. Now, when I talk about B class subnetting, now remember these questions will be a little bit different in calculation. Although we have to you know calculate the same things, all the five things. We have to calculate network address. We have to calculate first of all number of networks that we have when we divide this into subnets, and then we have to, for a particular case, we have to find number of hosts per network. And once I am done with that, I'll do what are the exact network addresses that I have to find each network address that I have, and then for one particular network I have to find the subnet, sorry, the valid host address range and the broadcast address. Right, so we'll start with B class networks, and we'll solve two questions for this, as there are two different cases for these questions. If we remember, if we want to understand subnetting in a simpler way, because this can get little cranky and little difficult if you don't understand it. So you have to just stick to those basics which we have done in C class. If you understand those basics, because you are able to solve it, and if you keep on doing the same stuff that I was doing earlier, you'll get the correct results. Otherwise, if you start doing those shortcuts, right, it will be difficult for you. You'll not understand what's the difference between B class and A class and C class subnetting. Right, so I'll start with B class address. So if I write a B class address, the range is from this 128. So I can write any network address now. So I'll write a network address like I'll write it as 128.100.0.0, which will put me in a default subnet mask or something. So this is how my B class subnet would look like if I talk about a bigger network, right? And I want to write this in both the forms. In slash notation I have already written. I want to write it standard notation, which is 25.25.0.0, and let me break this down into binary also, right? So I'll have to split this screen into two parts. So I'll tell you when I do that. This is how I write the subnet mask in binary when I talk about default subnet mask. Now, when I do subnetting, what do? I increase the number of ones in the subnet mask, isn't it? Right? And when I increase the number of ones, what happens? I'll take some example for now. So this is the first example I'm taking. So, for example, in my question, I'll get this. In my question, I get this, that I have divided this subnet mask using I've divided this network using a subnet mask //21. I'll use /18. So all right, so I have to write this slash 18 in expanded rotation, or before that I would like to write it in binary notation. So I will write slash 18 now. Just see carefully now what I'll do here. I'll write it as 0, 0, 0, 0. I'll write 18 zeros, sorry, 18 ones. So when I write 18 ones, so the rest of them I have to write zeros. So all the write 18 ones I have, right? And 18 so when I write 18 ones, 16 ones I already have. So the next two ones that I have taken, they'll move into third octet now, which will leave six zeros for me in the third octet. And then obviously I have to complete this 32 bits. So I'll write rest of the zeros also here. So this is my expanded, you can say, binary notation for the subnet mask slash 18. So I'll write the equivalent expanded notation here. 255 See, this first two fives are there, and the second is third octet that will be written as 1 1 and 6 0. So what is the binary? What is the decimal equivalent for this binary? This is 192, and the last octet will be 0. Convert this simple binary into decimal, I'll get the expanded notation. So I told you we have to write all the things. We have to write the subnet mask in slash notation, in also in the expanded notation, also the binary. Now you can clearly see there is some difference in the way subnet mask is being treated, right? So my changes are happening in third octet now, not in the fourth octet. This will give rise to something different here. Okay, so I'll get to the first question now, which is a very important part now, which is number of networks that I have, number of subnets that I have. I can write number of networks or number of subnets. So that will be 2 raised to n. Again, we follow that, where n is equal to number of ones that have been borrowed. So if I say how many ones which are borrowed, I can clearly see there were 16 ones already, and 18 ones which now I have. Obviously, I have borrowed only two number of ones, right? So my answer will be 2 raised to power 2, right? Which is equal to 2 raised to power 2 is equal to 4. So when I subnet using slash 18 subnet mask for B class addresses, right? I get number of networks as 4, right? So if I want to draw this, how it looks like, right? So this is how this will look like, right? So I'll have one network when I divide this using slash 18 subnet mask, and I'm talking about B class subnets now. Okay, all right. So I divide this into using this 18 subnet mask. I'll divide it into 4 networks. This is a visual representation of this. Okay, then I move to the next section, which is number of hosts per subnet. Now this is important. If you do not have done your calculations properly in this section, if you have not written slash value, also the expanded notation and the binary notation, you'll end up doing this part wrong, right? So number of hosts per subnet is 2 raised to power m minus 2, right? So what is m that I have? So 2 raised to power m minus 2. So I told you I have to write it carefully, so I'll write it like this also, so that you don't get confused. So this is 2 raised to power 2 raised to power m minus 2, where m is equal to number of remaining zeros. So how many zeros I am left with? So if you see here, to find those zeros, I have to just calculate those zeros from here, count those zeros from here. So how many zeros I have? These are 6 zeros here and 8 zeros here. I have to add up all these zeros. So the number of zeros that I have is 14. Now the pitfall that people generally fall into is that they calculate these zeros as 6 zeros. They forget about rest of the zeros there because they have been used to doing that in C class. Or else what they'll do is another mistake is that they think it is equal to seven zeros, which is again wrong. This is not six zeros. This is not a single zero that I'm talking about. When I'm writing single zero here in the decimal notation, I'm actually expanding it. If I write it in binary, it is equivalent to eight zeros that I'm writing over here, right? So eight zeros plus six zeros equal to 14 zeros that I have. M is 14 now, right? If you still don't understand that, uh, you just need to count this. This is where this binary bifurcation or binary representation of a subnet mark will be handy, right? This will help you in removing this error at this stage, right? So I have 2 raised to power m minus 2. So I have 8 plus 6 equal to 2. Now, for separating questions, you generally, when you have bigger calculations like 2 raised to power 16 minus 2 or 2 raised to power 20 minus 2 or something, you don't have to calculate that exactly, right? There's no point doing that. Nobody asks you to do that, right? So at certain point, you'll stop calculating the actual things. So you can keep this figure as 2 raised to power 14 minus 2, or else you can, if you can calculate 2 raised to, till 2 raised to power 14, that's fine, right? Because 2 raised to power 10 is 1024, and then 2 raised to power 11 is 1024 multiplied by 2, which is 2048, right? And then I have 4096 as 2 raised to 12, and 80 you know 8192 is for 2 raised to 13, and similarly something for 2 raised to 14. Since I don't want to get into this complexity of calculating this beyond certain point, so I'll keep this as 2 raised to 14 minus 2, which will serve my purpose. Okay. And then the next thing is, next section is what is my subnet address, what are my network addresses. Subnet addresses means I had one network whose network address was 150.100.0.0, and that is the network that I have written here, right? So this was one network that I have. This is the network address of this network. Now I want to find out network addresses of these four networks that I have: this network, this network, this network, and this network. Right, so I had four networks. I've drawn it here. I want subnet addresses of all these four networks. So how do I find that? Again, I keep sticking to my basics, right? So to find the subnet address, I got to the block. Block size is found by I go to 256 minus value of interesting octet. And what is the value of interesting octet? The octet which is changing is my interesting octet. Now here, which is the octet which is changing now? The third octet is changing, right? From 0 to 192. Right, so what is the value of interesting octet now? It is 192 now, right? So I have 64 as my block size, because if you subtract 192 from 256, the value will be 64. And which octet I'm talking about when I'm talking about interesting octets? Now this is a very you can say minute difference, or this is an important difference. The interesting octet that I'm talking about now is the third octet, right? The third octet is interesting octet. If you compare this, right, if you draw this is the octet that I'm talking about, third octet. So remember, the value of 64 is for third octet now, and since it is for third octet, I'll write it very clearly over here that this is third octet which I am talking about. Now this is important why I want to keep on writing this, because when I calculate now the subnet addresses, right, I'll write the base address, right? And I have to add the block size of 64. What is the block size? Which is 64. But I'll not add 64 to fourth octet. I'll add 64 to the octet which is the interesting octet. Write 150 dot interesting octet is octet third octet, right? So I'll add 64 to this third octet. So it will be 150.100.64.0, right? It will not be 150.100.0.64. That will be completely wrong. False also, which will fall into if you try to do something fancy, or if you try to calculate it in some other way, or if you don't stick to the basics. Again, I'll add the third octet, not the fourth octet. That is the difference between B class and C class. Then I have 128, right? What is and another network address is 150 dot I never write 256. I get the invalid value now, right? So I'll have something like this. So I'll not write this at all. So, so this is not the value that I'll write. This is my invalid value. So I had four networks, right? And all the four network addresses are here. Now remember, whenever I'm doing any kind of subnetting, if I get a bigger, a huge value of host per subnet, or if I get a lot of network addresses, something which you'll get keep on getting on in B class and A class questions and all. You don't have to write all the things. Now here there were only four networks, so I represented all the four. If I get 60 networks or 64 networks or 128 networks, you don't have to write all the networks. The only thing is you should remember how to calculate that. Now I've got till the third part. Get to the last part, which is again very important. A lot of people don't understand how do we calculate the last part of this, which is uh, valid host address range. Now, in submitting, this is a key skill how to calculate these things. And if you're not good with this, you'll end up with a lot of problems when we start doing some advanced topics like VLSM or something of that sort. Okay. So we have a valid host address range and broadcast address that we'll try to calculate now. So as for the example, we'll try to calculate valid host range for any of the four networks which is there. So what are the four networks that we have? 0, 64, 128, 192 in the third octet, right? So I'll take this network address, right? So I'll take this particular network address, this one, right? So I'll take 64 as something as my example, right? So I'll get to this now and see carefully what is there. So how many hosts that I have per sub in each subnet? We have 2 raised to 14 minus 2, which is a huge number, right? Which is somewhere around 16,000, right? So let's write those things. So obviously I'll not be writing 16,000 host addresses. So I'll just write the first few and then tell you what the real is. So how do I find the first valid host, right? So I'll always add 1 to it. When I add 1 to any of the addresses there, I always add 1 to the last octet. I'll not add 1 to the third octet because a lot of people do this thing also. This is again another pitfall, right? Don't fall into that trap. Right? Don't add 1 to the third octet because you have been adding 64 to the third octet. 64 I'm adding to third octet because I have calculated this using a block size. So block size was 64. That was for the third octet because third octet was changing. That was an interesting octet. That's why we changed it in the third octet. But when I'm doing it for valid host range, when I'm trying to find out what are the valid hosts, I'll add one, and one is always added to the right hand side octet, which is the rightmost octet which is there, right? So I'll add one here. So I'll get something. Don't write it as 65.0, which is absolutely wrong. So this is what. So if I keep on adding 111, I'll get to this number 150. Again 100.64 till 255 because that's the maximum value I can achieve in any octet, right? After 255, I cannot write anything. So once I reach till 255, right? Now remember in B class addresses, right? When I go until 255, what is the last address that I have to write in this entire series? The last address will be the next network that is there. What is the next network that I have? 150.100.128.0. So what is the next to last address that when I'm talking about this? I have to reach till this point, right? This which is the yeah, I'll write it here. My last network which is there is 150.128.0. option that I have. I have to go till this point, right? So what is the address that I have reached here? 150.100.64.255. So I have to move beyond this. So when this thing happens, now I cannot write 256 in the fourth octet. I have to add one here. One here. What do I get? This is 150.100.120.0 is something that I have to reach till. I have I have reached till point where I have calculated till 150.100.64.255. When I add 1 to it, right? So I'll add 1 to 255, right? So which is 256. When I cannot write something here because it is full now, so I'll change the third octet now, right? So next thing is 150.100.65.3, right? And then I keep on adding 1 to it, 150.65.1, right? Then 65.2, 65.3, right? So I'll have, I'll write it like this, 150.100.65.3, right? And then it will go on till to 3, 4, 5, 6, and again it will end up with 150.100.65.255. Again, when I add 1 to it further, I'll get this number 150.100.66, and then dot 1 till, and then finally I'll come to a stage when I'll reach this number 150.100.128.0, right? So this is the number that I'll get till. So what is the last address of this series? Because why I'm searching out the last address, right? So my maximum address that I am having, the next address that I have is 150.100.128.0, right? So what is the last address I have this one series? Because I want to find the broadcast address. That is, last address is the broadcast address. What is the last address is? One number minus 150 dot, so 150.100.128.0 minus 1. So what is the address that I am looking for now? It is 150.100.127.255. This is my broadcast address for this network which I am calculating it for. So my network is 150.100.64.0, right? The first address is 64.1 to 64.2, and it goes on till this. And then when I add the 1 to the last, when 255 comes in the last octet, when I add 1, it will move to the third octet, 65.0, 65.1, and it will keep on adding this till I get till to this point 255 or 255 to 127 or 255, right, which is my broadcast address. Why? Because when I add 1 to it, next network, which is 150.100.128.0. So this is the next network. So this is my broadcast address, right? And if I subtract 1 again from this, I'll get the last address, last actual address, last valid address, which I can write 100.127.255. Now when you subtract, when you try to write this broadcast and this, when you subtract 1 from each addresses, don't subtract from the third octet, subtract from the fourth octet, because when we add 1, we add in the last octet, again fourth octet. When we subtract 1, again we add to the, or subtract from the last octet. So this is my last address that I have. So this is my last valid host. Broadcast is 255, 128.0 is my next network, and which is my first network. So this is my, we never say that I want to write all the valid host addresses. I say valid host address range, right? So what is my valid host address range for this network now? 150.100.64.0, and I'm talking about /18, right? So if my questions come like this, 150.100.64.0/18, what is the broadcast address for this? The broadcast address for this is 150.100.127.254, 255 rather, right? And so this is my broadcast address, right? This is my broadcast address, and my valid host range is from this day. Yes, so I have valid host range from 150.100.64.110.127.254. So if you count these total addresses, right, these will come out to be 2 raised to power again that 14 minus 2. right? So this is how B class subnetting is done. This is how few questions of B class subnetting will go like, right? So that this is how we do a few questions of B class. There are other, you can say category of B class subnetting questions which we'll do in a little different way. But as of now, this is a half part of B class addresses. This is one half of how B class addresses look like, right? B class subnetting looks like. So I hope you are able to understand this. We'll move to the next section in which we'll do some other questions. But before that, I want you guys to give, ask me any doubts that you have. So we move on to this next section of B class submitting questions, right? So I'll move to these questions in which we have some kind of change in this question. So B class again we will move on to this question. I'll write any B class address here 150 dot 100 dot 100 dot 0 dot 0, and this is my default subnet mask. And so obviously I'll write it 155.255.0.0, and then I will write this into the binary form also. But this process seems to be very redundant. You think that we can do with this, but let me tell you, initially at some stage, at initial stages, don't try to skip this process, even if you know what I'm writing, because this will help you in reducing the errors that you have, because that is because of confusions. When you write everything and you have written it clearly, there are less number of confusions that you have, right? My next question for separating will be if I can, for example, if we get this question 150.100, I'll say 0.0. The slash value that I'll be using is it'll be greater than that 24 slash 24. So I'll write those kind of questions. So I'll write the question slash 29. Okay. So this is the value which I can write, right? In subnetting, what do? I convert number of zeros which we have into ones, right? And when I do that, I can convert any of these zeros into ones. So how many zeros I had in the default circle was 16. I can convert all of them into ones, right? Almost all of them, right? So I converted all of them and I arrived at the subnet mask. For example, if this is a question that I get at the subnet any kind of interview exam, so how do I solve this, right? So first of all, again, I have to go to this best basic step to write the binary of this. I'll write binary. This is our right binary for slash 29. So remember slash 29 when I mean for whichever class of IP addresses I'm talking about, whichever class of networks I'm talking about, slash 29 is written in the same way. Slash 29 is 29 ones followed by 3 zeros, right? So when I write the expanded notation, I convert this binary into decimal. Slash 29 is how much? So I'll write what is the binary of 5 ones and 3 zeros, right? So binary of 5 ones and 3 zeros. Alright, so this is what we have. Now there's something that I'll tell you the differences that you have to see when you compare this with the last question so that you don't find errors now. Now I have moved from slash 16 to slash 29. What I have essentially done is I'll try to draw this now. Okay. What I've essentially done is I have converted this entire octet of zeros, right? This entire octet, and it converted this into entirely into ones, right? And since this was not enough for me, I moved on to the next octet and I converted a few of the ones zeros here into ones, which is 5 zeros into ones, right? So then I arrived at slash 29. So remember this visual now. Okay, so I move on to this question which was there, right? The first question is number of networks that I have, number of subnets that I have, right? So what is the number of subnets that I have? 2 raised to power again n, right? So n is equal to the number of ones that I have, number of ones that I have borrowed. right? So what is the number of ones that I have borrowed? Earlier I had number of ones as 16 number of ones. Now I have number of ones which is 29. So the difference between these two, the number of ones which I have borrowed, right? So that is the value of n that I have, right? So I have to calculate these number of ones. I'll just draw it here again. I want to draw this here. So these are the number of ones I'm talking. These are the bits that I'm talking about. Right? These are the bits I'm talking about, right? So how many number of ones do we have? We have 8 plus 5. 8 plus 5 is how much? 8 plus 5 is 13, right? So number of subnets here is 2 raised to the 13, right? So I'll again not calculate it. You can calculate it if you want to, because 2 raised to 10, 11, 12, 13, you will be able to calculate it. So 2 raised to 13 will be equal to 8192, right? So if you don't want to calculate, you can leave it. So I'll get to the next question, which is number of host subnet, host per subnet. Right. Again, 2 raised to how many zeros we have left? We are left with only 3 zeros. 2 raised to 3, which is equal to 2 raised to 3 is how much? 8. Yeah. So 8 minus 2 is 6. 6 host per second. Now if we can divide this into smaller subnets and all, we get less number of hosts per subnet, but number of subnets are a lot more. Right? So we move on to the next question, which is there, which is subnet addresses. What are the different subnet addresses that I have? You have to be careful at this point also, right? Now remember, how many subnets do I have? I have 8192 subnets. Right? So how do I find the block size? So how do you find block size? This is very important step because we are going to mess up over here. Right? Block size is equal to, right, block size is found by subtracting from 256 the value of interesting octet. Now here I have two interesting octets because there are two octets which are changing. There is one octet which is octet 3, which is changing from 0 to 255. There is another octet which is changing from 0 to 248, right? I have marked both as octets, right? Both the arrows are there, right? So this octet has changed from all zeros to all ones. This octet has changed from all zeros to 5 ones and 3 zeros, right? So I'll have two block sizes here. So when I have two block sizes, I'll write it as 256 minus 255, which is the block size for third octet, which is equal to 1, right? That is third octet. That is for third octet. I have block size of 256 minus 248, which is for fourth octet, right? So 8, that is for fourth. So I have two block sizes. Now that is why I came up with this question. I told you there are two category of questions. Now there is one category of questions in B class in which we are playing around with third octet. There is another category of questions in which I have converted all the ones in third octet and I have moved to the fourth octet. Right? That's how when we move to those questions, we'll get two block sizes and I have to remember when I get two block sizes, right? And what is the immediate next step that I have to do? I have to write the subnet address list. And how do I write subnet address? I'll take the base address of the block size. Whenever the block size equal 0, I'll add the block size. Now I have two block sizes. Which block size I have to add? Now whenever I'll have two block sizes, I'll always add the larger block size or the rightmost side of the block and rightmost octet block size. So what is the rightmost octet I'm talking about? I'm talking about fourth octet now. I don't have to add this third octet immediately. If I have two block sizes I'm talking about, I'll write I'll use the block size which I have obtained from fourth octet first, and then I'll see about how do I use that block size which I have got from the third octet. So I'll write 8 over here. I'll add 8 over here, but I'll add 8 in the octet from which it is being generated. 8 is being generated from fourth octet, so I'll add 8. fourth octet, keeping the third octet as same. 100.0.8 plus 8 100.0.16. I'll keep on doing this till I get to this 150.100.0.248. Again, I'll add 8 to it. Now remember this. When I used to do this earlier in B class also, even in C class also, right? So I never used to do this during this subnet addresses. Now when I add 8 to it, what will I get? I'll get 150.100.0.256. I cannot write it, right? So what I do, right? I would again move to the third octet now, right? And why I have to do move to the third octet? Because my block size of third octet is 1. I have to change it sometime, right? So this is the time when I have to change it now. So add 8 to it, 150 dot 1.0. Why? Because when I add 8 to this fourth octet, I'll get 256 here. I cannot write 256. I carry over to the left hand side. So this is 1.0, right? So if you see, this third octet is changing from 0 to 1. So essentially that block size of 1 is coming into picture now. Now this is very important. You don't have to, stop your calculation at this point where you get till 248 only. You have to go this beyond and move to the third octet. And the reason is that we had two block sizes and the block size of third octet was 1, right? And why we got two octets in my block size is because I have two interesting octets there. And why is that? Because I have moved from slash 16 to slash 29. I have not moved from slash 24 to slash 29. If I would have been using a C class address or C class network, if that would have meant that my default separate mask would have been slash 24 and I would have moved from slash 24 to slash 29. But that was if I was using a C class network. Now I'm using B class network, right? So I am obviously starting from slash 16 till slash 29, which gives me, in this particular case, it gives me two octets as interesting octets and thereby generating two block sizes. Thereby, when I'm generating those network addresses now or subnet addresses now, I'm adding 88888 till I get to this point where I cannot add anything more to this fourth octet. Then I move to the third octet by changing this to 1. Again, see, this 1.0 has not come suddenly because I have changed 1 over here in the third octet. No, I've been keeping on adding 8 only. This 1 in the third octet only tells me that you have to touch the third octet also. You have to keep playing with the third octet also when the fourth octet is full. Now remember, the rule is you will touch the third octet only if the fourth octet is full. If the fourth octet is not full, you don't have to touch the third octet. Now fourth octet becomes 0 again. I'll again write add 8 over here. I'm not adding 1 over here. So 150.100. So 1.8 is there, right? And I'll again add 8 to this. Then I'll have 150.100.1.16 over here. And it will keep on going, and again I'll move to I'll get to a point where I get 100.1.248, right? So when I add 8 to it again, I'll get again 256 here in the last octet. Then my third octet will change to 2. This is how my networks will be generated, and I'll keep on getting networks. So the last network that I'll get is 150.100. Uh, right. So these are the number of networks, and if we calculate this number of networks here, right? So the total number of networks, if we have, we'll have 2 raised to 13 networks, right? Now a lot of people, when they calculate this subnet addresses, they keep on writing this is the broadcast or something. Now remember, we have not even come to the point where we're starting to calculate those, you can say, uh, valid host address range or even broadcast addresses. What we are calculating as of now is only subnet addresses. So there is no point I'll say there's something called broadcast or something. These are all the subnet addresses. Now I come to the last part of this question, which is finding the valid host address range. Valid host address range. So what are the valid hosts that I have for a particular network and the broadcast address. This will take hardly a minute, maximum 2-3 minutes. So So my valid host range, I'll pick up any network which is there. For example, I'll pick up this network. I'll just mark this network which I'm picking. So I'll pick this network, right? This one. So my network I'm talking about is 150.100.1.8, which is one of my networks, right? So 100.1.8 is my network. So how do I find the valid host range? By adding one to it. So I add one to it. When I add one to it, one is always added to the right hand side of, so you can say, right now the rightmost octet. So 150.100.1.9 is my first address. So this is the first valid host range. And next address, immediate next address is what? Immediate next address is 150.100.1.10, right? 150.100.1.11. It will go until what point? It will go until next network. What is my next network that I have? My next network is 16 here, right? 1.16. So I'll write this next network here. 150.100.1.16 here. My next network, so I obviously cannot write it here. So what will become to the broadcast address? Okay, 1 minus this 1.15. This becomes my broadcast address. This becomes broadcast address for the network, which is 150.100.1.8. This is broadcast address for this network. And what is my last valid host here? Last valid host is 150.100.1.8. So if I calculate how many addresses that I have in this network, it's from 150.100.1.9 till 1.14. So the total number of addresses that I have, if I calculate this, is 6. Right? If you try to find out how many addresses that I have is from this particular number till 14. Right? I have total of 6 addresses. So this is what I have to keep in mind regarding calculations and all, that we end up in matching everything. So number of submits is here. I have matched it up here to raise with 30. Number of hosts is this. If some things don't match or something, try to see which pitfall you have fallen into, which trap you have fallen into, right? So these are the two questions that I did for B class, and this almost covers up entire submitting. For A class also, nothing will fall beyond this category, but still we'll keep on doing those A class questions. I'll do 3 A class questions in the next sessions, and we'll be done with submitting. Although we are done with submitting, so you can do 2 questions on your own for yourself. So the category of questions, the first category of questions that I did earlier during this session, right, in which I was playing around only with one octet as block size, right? I can do this question. I'll show this side for your home assignment or something. So this is 150.100.10.0 slash do it for slash 20. Okay. And another question which I just did now, right? When I transitioned from the second octet to third octet, and third octet was full, and then I moved to the fourth octet, right? 150.100. I'll say dot 10.0. Just write it as 0.100.0 slash do it for slash 25. So these are 2 questions you can practice around with, and in the next session I'll see you next time, and I'll give you questions for A class. Okay, and if you have any questions, you can again start asking me questions. So I'll wind this session now. I'll meet you for the next session for A class submitting, and then we'll move to VLS and all.